Good evening, ladies and gentlemen. This is your recording for lesson 2.2. Hopefully your assignment went well during class today, and we are going to go ahead and move on from section 2.1 to 2.2. So in 2.1, we were just writing those equations. You were not solving them. We were simply just translating those from a paragraph or from a sentence into a mathematical equation. Okay, so today we're actually going to be moving into solving those. I need to remind you what a solution to an equation is. Remember, a solution to the equation makes the equation true. When you plug it in, when you take that variable out and you plug in the solution, it should make the equation true. We are going to be talking about linear equations in one variable. Notice I have that one capitalized and underlined. There will only be one variable. It'll all be x's, it'll all be y's, it'll all be g's, it'll all be m's. There will not be two different variables. And the highest power, meaning the exponent that you will have on these, is 1. Now, typically, folks, you don't see x written to the first power like that. If it's just an x, it's assumed that there's a little first power up there. Okay, so these things will have a highest power of 1, and they will only have one type of variable. Now, when we are solving linear equations in one variable, there are 3 different possibilities. Okay, you can either have one solution, you can have no solution, or you can have infinite solutions. Okay, and we are going to be focusing today on just having one solution. Eventually, we'll get to equations that have no solution or infinite solution. In order to solve these things, you have to isolate the variable. Okay, and this should not be anything new to you. You probably did it last year in pre-algebra, but just in case, isolating the variable means you need to use inverse operations. Now, inverse operations just mean opposite operations. So, for example, adding and subtracting are inverses, multiplying and dividing are inverses. And you're going to use inverse operations to get the variable alone. And when you do that, you will then know the solution for the equation. Okay, so we are going to go ahead and do 13 examples here in your notes, and then you're going to need to pull out handout 2.2, and we'll do the 5 problems that are on handout 2.2. All right, we're going to solve this. So everybody sees that I'm trying to figure out what m is. Now, it's probably pretty obvious what m would have to be for this equation to equal 11. But we're going to go ahead and get into the practice of using inverse operations. So m has a -6 on it. The opposite of -6 is +6. So we're going to do that to both sides. When you do that, the -6 plus 6 cancels out. All I have left over here is an m and then my equal sign. And then 11 plus 6 is 17. So please notice the m is now isolated. It is all by itself. So it looks like my answer is 17. Now, in order to check it, you take that 17 and you would put it right back in here for the m. So it would be 17 minus 6. And you'd ask yourself, does that actually equal 11? And yes, it does. So 17 is the correct answer. Okay, moving on here. Number 2. Notice that r has a plus -48 on it. So I need to do the opposite of this -48, which is positive 48. Whatever I do to one side, I have to do to the other. Those will cancel each other out, and all I'm left with here is r equals, and then -50 plus 48 is -2. So it looks like that is my answer because the r is now isolated. I'm going to take this -2 and I'm going to plug it in right there. Does this actually equal -50? And yes, it does. So we know that -2 is in fact the correct answer. Moving on down here to number 3, I've got to try and isolate this d. So in order to do that, I have to do the opposite of that negative 61, which is adding the 61 to both sides. The minus 61 plus 61 will cancel, and I just have the d over there on the right side of the equation. If I compute the left side of the equation, this gives me a 43, and the d is isolated, so that looks like my answer. I'm going to take this d and I'm going to plug it in right here, and I'm going to ask myself, does this actually equal 18? If you type that in your calculator, it does, so 43 is the correct answer. Now remember, folks, as we're going through here, you should be pausing this to work out the problems. You should be making notes if you have questions for me when you get back into class tomorrow. Number 4, I need to isolate that y. Well, it's got a minus 2.78 on it, so I need to do the inverse to both sides. Those will cancel. I will have y equals, and then you're going to compute this. Now, this is where you should be stopping, you should be picking up your calculator, and you should be calculating this. Okay, you need to be an active participant in this video. I'm getting negative 1.42. So I'm going to go ahead and I'm going to take that negative 1.42 and I'm going to put it in for y. I'm going to type it in my calculator and ask myself, does it actually equal negative 4.2? If it does, then it is the correct answer. Number 5 here, I need to isolate this h. So I need to get rid of this 140. Well, it's positive, so I will subtract it in order to cancel it out. H equals, and if I subtract those two, I get 60. Now remember, you can go ahead and you can plug in this h right here and figure out if it actually equals 200 to see if you are correct. So folks, basically, when you take a test or a quiz over this, you should be able to know what questions you get right and which questions you get wrong. If you have time, you should be going back and checking your answers. All right, let's isolate this g in number 6. I'm going to need to subtract 3/4 from both sides. This gives me g equals, and go ahead and calculate what do you get there when you subtract 3/4 from that negative 1/8. I'm getting negative 7/8 for g. And again, the g is isolated, so that is my answer. All right, if you look at numbers 7 and 8 here, you will see they are very similar. They both have this minus a minus. Well, you know that if I've got two negatives back to back like that, I can rewrite that to be a plus. And you should rewrite that because now I can go ahead and isolate. W equals 1. Do not try and isolate with those minuses back to back up there. Please rewrite it first. We're going to do the same thing with number 8. I'm going to rewrite it. Now we're going to isolate that R. So calculate what you're going to get on the right-hand side over there, and you should get negative 90. Reminding you that you can take this negative 90, you can plug it in right there, and then when you type that in your calculator, it should give you a negative 77. All right, so all of those problems were adding and subtracting. Let's move on to some multiplying and dividing problems now. You'll notice this says 4 times t, 4t. Well, the opposite of multiplying is dividing. So, in order to isolate the t, we're going to divide by 4 because that's the opposite of multiplying by 4. When you do that, I get t isolated, and this gives me 9.5. Take that 9.5, plug it in right here. If I do 4 times 9.5, does that actually give me 38? It does, therefore it is the correct answer. Number 10, this says 2 1/4 g. Now, If you don't like that mixed number up there, you could rewrite it as an improper fraction. Remember how you do that. You take the whole number of 2, you multiply it by the denominator of 4, that gives you 8. Then you add the numerator of 1. So this is the same as 9 over 4g equals 112. So you can solve these either way. You can leave the mixed number or you can deal with the improper fraction. I'll do it both ways just to show you how this works here. We're going to divide by the 2 1/4 to isolate the g. 112 divided by 2 1/4 will give me g is 49 7/9. Let's do the same thing with the improper fraction. We would divide by 4/9 on both sides. Divide by 9/4 on both sides, and you get g equals, I'm hoping it gives me the same thing, and it does. You still get 49 7/9. Now, that was a fraction, okay? I'm not sure how long it's been since you talked about multiplying and dividing fractions, but if I divide by 9/4 like we did right here, when you divide by 9/4, that's the same as multiplying by the reciprocal. So if I did 112 and multiplied by the reciprocal, now the reciprocal is flipping that thing over, which is 4/9. If you do that, that is the same thing that you get if you divide by 9/4, and that does give you the same 49 7/9. Okay, so I just want to recall that information that when you divide by a fraction, it is the same as multiplying by the reciprocal. All right, number 11 here. Notice I just have a negative symbol in front of there. That negative symbol needs to be gone. I need to cancel it out. Okay, this is like having a -1 in front of there. So in order to get rid of that, the common mistake is to add 1. We are not adding 1 here, folks. That is multiplication. So we need to divide by -1. And you get u equals -0.35. Okay, so again, if you were to check yourself here, you would be putting that in right here for u, and it would look like this. Those two negatives there would cancel out, make a positive, and then that would be a true statement. All right, number 12 over here. Notice that y is being divided by 5. The opposite of dividing by 5 is multiplying by 5. And we're going to do that to both sides. So I get that to cancel. Y equals, and then we're going to calculate this. And I have y equals -225. All right, one more down here. And I want to kind of explain a little bit on this one. You'll notice that negative sign. Now, I've put that negative sign right out front of that fraction. You need to understand that this fraction is the same as this fraction is the same as this fraction. All three of those things are the same. You can put the negative out front, you can put the negative in the numerator, you can put the negative in the denominator. You just cannot put the negative both places at the same time. So for our purposes, let's pretend that this negative symbol is in the denominator. So now it's being divided by -3. Well, the inverse of that is to multiply by -3, which means those will cancel, and I have f equals, and that will give me 54 for my final answer. Okay, folks, so we were just solving some one-step equations here. Let's go ahead and translate that into some word problems. So if you'll please go ahead and get out your handout 2-2. We're going to go ahead and do those 5 problems there next. Notice this time it says we're supposed to define a variable. So if there's not a variable there, you need to come up with your variable. Then you need to write your equation, and then you actually have to solve that equation. A record for the most snow angels made at one time was set in Michigan when 3,784 people participated. North Dakota had 8,910 people register to break this record. Write and solve an equation to determine how many more people North Dakota had than Michigan. Well, I want to know the people in North Dakota. That's what they're telling me to find. So let's call that X. Okay, if I'm going to write an equation, there's two different equations you could write here. I could say, okay, the people in North Dakota plus those people that were in Michigan, that would have to give me the total altogether, and that would tell me how many more people were in North Dakota than in Michigan. Okay. The other way you could do this is you could say, okay, I know I've got a total of 8,910 people registered in North Dakota. If I subtract the people in Michigan, that will give me how many more I have. Now, if you look at this equation over here, X is already isolated. All you have to do is subtract, and you get an answer of 5,126. On this equation, if you're going to isolate the variable, you need to subtract, and you'll notice you're doing the same exact thing that we did over there, and you will get the same exact answer, okay, no matter how you write that equation. Ricardo is driving 780 miles to Memphis. He drove about 3/5 of that distance on the first day. About how many miles did he drive? Okay, so I'm trying to find how many miles he drove on that first day. Okay, let's call that X. He drove 3/5 of the distance. So 3/5 of means to multiply of the distance. Well, the whole distance is 780. That'll give me how many miles he drove on that first day. Notice the X is already isolated. All you have to do is multiply 3/5 times 780, and you get that X is 468 miles. An electronics store charges $126 for a certain camera. This is 2/3 the price that a photography store sells it for. What is the cost of the camera at the photography store? How much more is it there? So I want to know the cost of the camera at the photography store. Let's call that X. It says here, this is 2/3 the price. So 2/3 of the price at the photography store is equal to the price at this electronics store. So if I want to isolate that variable, I'm going to divide by 2/3. Now remember, a few minutes ago, I said dividing by a fraction is the same thing as multiplying by the reciprocal. So when we actually divide this, it gives me $189. If you were to take this 126 and times it by the reciprocal, which means flip it upside down, you will still get that same number of 189. It's just personal preference whether you want to divide by a fraction or multiply by a reciprocal. Now, I haven't quite answered the question yet because it says how much more is it there. So I want to know what the price difference is. If I paid $189 at the photography store and $126 at the electronics store, that is $63 more. So make sure you finish and answer the entire question. In 2006, 57 million Americans read online blogs. However, 45 million fewer Americans say they maintain their blog. How many million American adults maintain their blog? Well, this is what I'm trying to determine. Let's call that X. Okay. It says 57 million read the blogs. 45 million fewer maintain their blogs. Okay, so fewer means to subtract. So I can do one of two things. I can take this 57 and do 45 fewer, and that's going to tell me how many maintain their blog. Or I can say, okay, if I know how many maintain their blog, if I add the 45, that should give me the total number of people that actually read them. No matter how you slice it here, you're going to get the same answer. Over here at this equation, the X is already isolated. All you have to do is subtract, and you'll get that X is 12. Over here, we have to isolate our X, but we're doing the same operation. We are still subtracting, and we will still get that X is 12. All right, last one here for us, folks. According to the Bureau of Labor and Statistics, approximately 140 million people were employed in the United States in 2009. Part A, the number of people in production occupations times 20 is the number of working people. So the number of people in production occupations times 20 is the number of working people. That's the key here. Write an equation to represent the number of people employed in production occupations in 2009, then solve. Well, I don't have a variable for that. People employed in production occupations, let's call that P. Okay, let's go back and reread that sentence. It says, the number of people in production occupations is 20 times the number of working people. 20 times the number of working people. So if I take my production occupations and multiply it by 20, that should tell me how many working people there are. Looks something like that. Now I need to solve that. So in order to isolate, we'll divide by 20. And I get there are 7 million, people in the production occupations. Part B. The number of people in repair occupations is 2,300,000 less than the number of people in production occupations. How many people are there in repair occupations? Well, I already have a variable for these people in production occupations. It's P. And it says the people in repair are this many less. So I'm going to subtract, and that should give me the number of people in those production occupations. Well, I know that that's 7 million. I'm going to try and fit this in here. Looks something like that. So I had to use my answer from part A in order to be able to calculate part B. Well, in order to isolate in part B, we're going to add this over. Sorry, I'm running out of room here, guys. So P equals, and you would get 4,700,000. Okay, that completes today's notes. You have a notes check that is 4 problems to complete, and then I will see you guys tomorrow morning.